Good day. My name is Sipu Senkosi Ele. I'd like to demonstrate my honors year project. So as you can see, the main focus of the project is generative pre-trained transformer. Let me go to the next slide. The agenda of the demonstration that I'm going to use: introduction, problem statement, proposed solution, transform architecture, and then model specifications. So let me go to the next slide. So the main purpose of this demonstration is to overcome delays in customer response. I'll go more into details on the problem statement. Let me go to the next slide. So the introduction. The introduction, I'm using a machine learning. In the machine learning, I'm focusing more on deep learning. So I'm using machine learning to solve high volumes of inquiries, can greatly improve the efficiency and accuracy of responses, especially in scenarios like customer service, technical support, or information request. So I'm using a machine learning to develop a model that can improve the efficiency and accuracy of responses in customer service. So my model is focusing more on natural language processing for text understanding and then text generation. Let me go next. So this is the problem statement of the research. One, the high volume of inquiries. Think about the company like Amazon. Amazon is a huge technology company of which they are getting inquiries, a lot of inquiries. Then they're also getting a lot of customer queries from customers. So think about the hardworking employees that are going through solving these inquiries, responding to customers for these inquiries, and then also solving the queries for customers. So the model is focusing more on those type of problems, the model that I developed. The second one is inconsistent service quality. Service quality, it's depending on the human. Some people they grow up with respect. Some people they're capable of respecting customers. Some people they can't respect customers, they just talk. And then without realizing that they're frustrating the customer. So the third one is low response time. Customers don't like to wait for 2 weeks to get the response. If they want to purchase a product, you have to give them all the resources they need. Let me go next. So the next slide is focusing more on the proposed solution. So my solution to solve the previous problem that I will take you through is to build a generative pre-trained transformer for customer assistance. So a solution to develop a GPT-based customer assistance model that can understand and respond to inquiries, and then solving customer queries as well. It's text generation, it's understanding human language. So the benefits of the model is automate customer interactions, provide intelligent responses, and then ensure scalability to customers. So the ensure scalability is when you can apply the model or you can use the model to any different type of application you want to use. For example, machine translation, text generation, text classification, and then text summarization. So on my right hand side, this is how to build a GPT model. This is a sequence that I was following that really helps me a lot to build the GPT model. So let me go to the next slide to get into more details. So the next slide is explaining the transform architecture. What is a transform architecture? Transform architecture is a deep learning model introduced in the paper Attention is All You Need that has become foundational in natural language processing task. It has since been widely adopted for various tasks such as machine translation, text generation, summarization, and then more. Like I explained before, transform architecture is unlike traditional sequence model. For example, recurrent neural networks. or long short-term memory networks. The transformer relies entirely on attention mechanism and does not require sequential data processing, making it highly parallelizable and efficient for training on a large data sets. So let me explain each the embedding layer, input embedding layer. So each word and in the sequence is converted into a vector of continuous values through embedding. This allows the model to represent words in a high-dimensional space. So, what is a multi-headed self-attention mechanism? So, multi-head self-attention mechanism is the self-attention where the core innovation in the transform architecture is the self self-attention mechanism. It enables the model to look at other words in the sequence when encoding a particular word, helping it capture dependencies across the entire input sequence. So, what is a feed-forward neural network? So, the feed-forward works after self-attention. The output is passed through a feed-forward neural network applied independently to each position in the sequence. This helps with transforming the attended values into higher level representation. So what is a residual connection and layer normalization? So residual connections or skip connections are applied around both the self-attention and then feed-forward layers, helping to avoid the vanishing gradient problem and allowing better gradient flow during backpropagation. So during a backpropagation, sometimes we encounter vanishing gradient problem, of which where the model is what won't give you the accurate response because of the weight and passes, the gradients are finished. So what is a stacking multiple layer? Stacking multiple layer works with the both encoder and the decoder of the transformer consists of multiple layers of self-attention and then feed-forward networks. This stacking allows the model to learn increasingly abstract representation of the input. So what is the encoder and the decoder structure? The transformer model consists of two main parts, encoder and the decoder. The encoder is the part that reads and processes the input sequence. It is composed of multiple identical layers, each with a self-attention mechanism and a feed-forward network. So what is a decoder? Decoder generates the output sequence one token at a time, similar to encoder. It is also has multiple layers, but each decoder layer has an additional encoder and a decoder attention mechanism that tends to the output of the encoder. This allows the decoder to focus on relevant parts of the inputs while generating the output. So what is the attention mechanism variance? So attention mechanism variance focusing more on two parts, self-attention and then the cross-attention. In the self-attention, the encoder and the decoder self-attention allows the model to process the input and output sequence by attending to all other tokens in the same sequence. So the cross-attention in the decoder, cross-attention mechanism attend to both the input from the encoder and the output sequence generated TOEFL. So this enables the model to generate output tokens that are conditioned on both the target sequence and then the input sequence. So the output layer, the decoder outputs a sequence of predicted tokens by applying a softmax layer to the decoder outputs. The predicted tokens are generated one at a time in an autoregressive manner where the outputs from the previous step is used as an input for the next step. So let me go to the next slide. So the next slide is focusing more on the model specifications. The activation function that I use on building the model is a ReLU. What is an activation function? What is a ReLU? Is an activation function used in neural network, particularly in deep learning models. It is one of the most widely used activation function because it introduces non-linearity to the model while being computational efficiency. So the learning rate that I used is 1E3, of which the learning rates control the size of the update in the networks. It's mostly used in the optimizer. What and then the optimizer that I used for the model is adaptive momentum estimation, usually known as ADAM. So my optimizer is more important when the model predicted the wrong output and then calculating the gradient and then start to do the back propagation. The optimizer update the weights and passes for us in the network so that we can get the accurate response. So the loss function that I use is binary cross entropy. Binary cross entropy calculates the loss and then calculate the gradients and then give us the predicted probability. So let me go. The next slide is the development tools and the technology stack, the hardware and the schedule, CPU for training the model, Visual Studio for backend Python, front-end HTML and CSS. The framework is Autoregressive Language Modeling Framework. I use a little bit of a PyTorch for training the model. So let me go straight into demonstrating. Let me go straight into demonstrating the model functionality. So this is the application that I developed. As you can see, generative pre-trained transformer applications, model developments, application services, and then autoregressive model, and then the customer service. So let me not spend time on going through everything because of time. So let me go straight into the functionality. So the customer service, this is where you write a customer writes a message and then click the send button and then we get the response from the model. So right now, as you can see, there's nothing in here after I send the prompt and then the model will give us a response. So let me write hello and then click send message. Right now it's the backend, it's calculating, doing the model functions, and then it's generated the response to us. As you can see, hello, I will clean some of the words doesn't make meaning because of I'm still doing the training accuracy and then also implementing the fine tuning in the model. So let me just say how are you on the model. Are you, and then the model will give us the outputs. So let me click send the message. So as you can see, and then it's giving us the generated text, the response from the model. How I was though some of the words for now are not making sense because of I'm using the training data sets at the moment. So I have to implement the test data sets to make and then improve my fine tuning so that the model can predict accurate information. So thank you very much. Let me stop here the demonstrations. Thanks. I really appreciate it.